The gas giant Saturn has 292 moons. Yet within this spectacularly vast system, there's one moon that's instantly recognizable. With a colossal impact crater dominating its surface, Mimas looks more like the Death Star than a natural icy satellite. Its ominous crater was first spotted when the Voyager probe sped past in 1980. Almost instantly, scientists attributed it to an ancient collision of epic scale. But since then, the moon has hardly changed. Compared with the likes of the active moon Enceladus and Titan, Mimas almost seems boring, relegated to just another cosmic fossil, a simple reminder of how violent the early solar system must have been. That is, until 2024, when scientists found that hidden beneath its ancient, cratered shell lies something that simply shouldn't exist. Mimas is not dead, it's an ocean world. This discovery has transformed the Death Star moon from a celestial curiosity into one of the most important objects in our search for life beyond Earth. But how did we get Mimas so wrong? And just what lies beneath its surface? I'm Alex McColgan and you're watching Astrum. Join me today as we peel back the icy crust of Saturn's innermost moon to reveal a secret ocean hiding in the dark, and delve into what this maritime discovery on Mimas means for the rest of the Saturn system. Mimas is a tiny moon. It orbits around 186,000 kilometers from its host planet Saturn, and with a mean diameter of just 400 kilometers, it's actually the smallest astronomical body we know of to have pulled itself into a spherical shape due to its own gravity. For the most part, Mimas doesn't seem that special. It's not overly dissimilar to many of Saturn's other mid-sized moons like Tethys, Dione, and Rhea. But what makes it stand apart is the fact that Mimas is a world whose history is clear to see on its surface. And that history is one of unimaginable violence. The surface is heavily cratered, but one feature is particularly prominent. Mimas is dominated by the Herschel Crater, an impact basin 130 kilometers wide. To put that in perspective, the crater covers nearly 1/3 of the moon's diameter. If a crater of the same relative scale existed on Earth, it would be more than 4,000 kilometers wide, larger than the entire continent of Australia, with walls towering more than 150 kilometers into the sky. To help you imagine just how crazy that is, think of this. Mount Everest doesn't even quite stretch to 9 kilometers. The impact that created this epic crater was a cataclysmic event that brought Mimas to the very brink of destruction. Simulations suggest that if the impact had been just a little bit larger or moving slightly faster, Mimas would have shattered completely, reduced to just another ring of debris orbiting Saturn. Luckily for us though, the moon survived. Shockwaves from the impact traveled through the moon's core and focused on the exact opposite side, the antipodal point, where they ripped the crust apart, creating a complex network of canyons and fractures known as chasmata. For decades, planetary scientists looked at this battered surface and concluded that Mimas must be frozen solid. A warm, slushy interior would have relaxed over time, smoothing out the crater walls and erasing the scars. The fact that the Herschel crater still stands, with walls 5 kilometers high and a central peak reaching up to 6 kilometers, suggests that the ice shell was rigid and immensely thick, supporting these massive structures for billions of years. Essentially, everything was pointing to Mimas being a geologically dead world. That is, until scientists found something strange happening on the surface. Their clue that they'd got something wrong came later, through the Cassini mission. This makes sense. Reviewing information is the best way to see if your initial assumptions are mistaken. When I studied for tests at uni, I found that repeatedly practicing test questions was my best way to overcome gaps in my knowledge, especially when I had someone there to guide me through the answers. Science may not have gotten that level of feedback from Mimas, sadly, but if you're looking to enhance your learning, you don't have to be left so adrift. Instead, try Brilliant, the sponsor of today's video. I really enjoy Brilliant. It's an online learning platform for students looking to learn maths, science, and coding, and its style is right up my alley. It teaches through asking interactive questions and breaks down concepts step by step, like having your own personal tutor. I tried out its probability and chance lessons recently, and I found it a much more enjoyable way to learn than through reading textbooks. It was fun, and when I got something wrong, its feedback was immediate and helped me easily see what I'd misunderstood. Its courses are designed by world-class teachers from MIT, Harvard, and Stanford, so if you're a student or have kids who are looking to enhance their learning, scan my QR code or click the brilliant.org/Astrum link in the description below. Doing so will give you 20% off an annual premium subscription for unlimited daily access to all Brilliant has on offer. Plus, there's a 30-day free trial. For Mimas though, there was no learning platform to show scientists where they'd gone wrong. They had to figure it out with Cassini. In 2010, NASA's Cassini spacecraft swept past Mimas and turned its composite infrared spectrometer towards the moon to map its surface temperature. Scientists expected to see a smooth gradient, warmest at the equator where the sun was overhead, and fading to cold near the poles. Instead, they found Pac-Man. Yes, you heard me correctly. The thermal map revealed a sharp V-shaped boundary on the moon's leading hemisphere. Inside the mouth of the shape, the temperatures dropped to an icy -196 degrees Celsius, while the surrounding regions were a relatively balmy -181 degrees Celsius. It was a thermal footprint that looked exactly like the 1980s arcade icon eating a dot. The dot, in this case, being the Herschel Crater. Even more surprising? When you look at Mimas in visible light, this difference completely disappears. The surface looks totally uniform. Nothing at all correlates to the anomaly we observe. This led astronomer Dr. John Spencer to playfully joke that Mimas might actually be the Death Star, and that Darth Vader simply applied a clever coat of paint to fool our visible light cameras, hiding the truth from everything except the prying infrared eyes of Cassini. Now, this thermal anomaly wasn't exactly a sign of internal heat, but rather a sign of how Mimas interacts with its environment. You see, Mimas orbits right inside Saturn's radiation belts. The moon is constantly bombarded by high-energy electrons trapped in Saturn's magnetic field. These electrons slam into the leading face of Mimas, welding the powdery snow regolith into hard-packed ice crystals, a process called sintering. Now, this hard ice has high thermal inertia. That means that, just like a dense rock on Earth, it absorbs heat during the day and conducts it deep underground, leaving the surface cool. At night, that stored heat radiates back out. The mouth of Pac-Man, on the trailing side, is sheltered from this bombardment, so the surface there remains relatively fluffy and powdery, acting like an insulator that heats up quickly in the sun but holds no heat at night. This solved the mystery of the thermal map, but in doing so, it also reinforced the idea that Mimas was a passive object. The anomaly was due to surface effects rather than anything internal. But whilst Mimas is known for its surface features, it's governed by something else, its gravitational dance with Saturn, an interaction that creates one of the most famous features in the solar system. If you look at Saturn through a telescope, you'll see its glorious ring system. And if your telescope is good enough, you'll see a dark gap splitting the rings in two. This is the Cassini division, a 4,800 kilometer wide chasm separating the A ring from the B ring. This gap exists largely because of Mimas. Mimas orbits Saturn once every 22 hours and 36 minutes, and particles orbiting within the inner edge of the Cassini division circle Saturn exactly twice for every one orbit of Mimas. This is a 2-1 orbital resonance. Every time Mimas completes an orbit, it tugs on these ring particles at the exact same point in their path. It's like pushing a child on a swing. If you push at the right moment every time, the swing goes higher and higher. Mimas's gravity adds energy to these particles, stretching their orbits into ellipses until they collide with other particles or are ejected from the gap entirely. For years, before Voyager flew past in 1980, revealing the Herschel Crater, this resonance was the primary claim to fame for Mimas. It was the Sheppard of the rings, the gravitational influence that kept the Cassini division clear. But recent simulations have suggested that Mimas didn't just clear a pre-existing gap. Instead, it may have acted more like a snowplow. Standard planetary system models suggest moons migrate outward over time. But in 2019, when researchers Kevin Bailey and Benoit Noyel were attempting to explain why the Cassini division was so wide, they found this couldn't be the case here. Their theory instead suggests that Mimas migrated inward towards Saturn somewhere between 4 and 11 million years ago. As it did so, its resonance moved with it, pushing ring particles aside and carving out the division over millions of years. This interaction is crucial because it tells us that Mimas is not dynamically static. Its orbit changes. And it was this orbital movement, specifically the way Mimas wobbles, that led to the most recent revelation about this tiny world. Before we get into exactly what scientists found about Mimas, we have to address an elephant in the room: Enceladus. Enceladus is Mimas's neighbor. It's roughly the same size, composed of similar materials, and orbits just outside Mimas. But Enceladus is spectacular. It has tiger stripe fractures at its south pole that blast geysers of water vapor into space, creating Saturn's E-ring. And we now know Enceladus has a global subsurface ocean that is warm and potentially habitable. I have another video on the latest discoveries here if you want to take a look. The problem is that according to standard tidal heating models, Mimas should be the active one. Mimas is closer to Saturn than Enceladus, and its orbit is much more eccentric. Both of these factors mean that tidal heating, the friction generated inside a moon as it gets stretched and squeezed by gravity, should be much stronger. The math says that Mimas should be experiencing significantly more tidal heating than Enceladus. So, why was Enceladus melting while Mimas looked like a frozen block of ice? This is what researchers have long called the Mimas paradox. The prevailing theory was that Mimas was simply too cold. If a moon freezes solid, its ice becomes rigid and it can't flex. This means that it doesn't generate friction, instead entering a state of high Q or quality factor, which implies low dissipation. Imagine hitting a bell. The energy isn't absorbed, instead the bell rings. Enceladus, for whatever reason, stayed warm and slushy, allowing the tides to keep adding energy to its interior. Mimas, on the other hand, we assumed, missed its window. It froze early and stayed frozen. But that isn't the end of the story. In 2014, researchers noticed something wasn't quite right. They measured the libration of Mimas, the slight wobble it experiences as it rotates. This wobble was almost twice as big as it should have been for a solid body. Now, at the time, there were two possibilities. Either Mimas had a strangely shaped core, elongated like a rugby ball, or its ice shell was physically disconnected from its core, sliding around on top of a liquid layer. Most scientists bet on the rugby ball. A notion just didn't make sense given the thick, ancient crust. But then came 2024. In February of 2024, a study published in Nature Astronomy put the debate to rest. A team led by Valérie Leyne analyzed the drift of Mimas' orbit using data from the entire 13-year Cassini mission. Just as Mimas pushes on the rings and Saturn push back, causing Mimas' orbit to precess. Essentially, the oval of its orbit slowly rotates around Saturn. The rate of this precession depends heavily on the distribution of mass inside the moon. When the researchers plugged the data into their models, the rugby ball core theory fell apart. It couldn't explain the so-called orbital drift I just described. There was only one solution that fit the data perfectly. Mimas has a global subsurface ocean. But this isn't an ocean like the one on Europa or Enceladus. It's what I'm going to call a stealth ocean. It lies beneath an ice shell that is 20 to 30 kilometers thick. What's particularly interesting is that the researchers believe this ocean is incredibly young. The models suggest it formed between just 2 and 25 million years ago. This young age of the ocean is crucial. In fact, it explains everything. The ocean is so new that the heat hasn't had time to radiate through the thick, ancient crust. Essentially, the moon is melting from the inside out, and features that formed long before the ocean formed, like the Herschel Crater, haven't yet been impacted. This discovery resolves the Mimas paradox. Mimas isn't dead, it's just late to the party. You might even say it's an Enceladus in waiting. Given enough time, the ocean will continue to eat away at the ice shell. In a few million years, the stresses will become too great. The crust will crack, and Mimas might begin to spray its own geysers into the Saturnian skies. Now, the realization that Mimas has a young ocean leads to all sorts of fascinating possibilities. But there is one gaping question. Where did it come from? It turns out that the most likely culprit is actually its orbital instability. At some point in the recent past, perhaps just 10 million years ago, Mimas likely entered a chaotic resonance with another moon, possibly Tethys or Dione. This interaction would have pumped up Mimas' orbital eccentricity, stretching its orbit into an even more extreme oval. As Mimas swung closer to and further from Saturn, the immense tides were now powerful enough that they began to flex the moon's solid interior. The friction generated heat, enough heat to melt the ice and create a global sea. And then there's the even bigger question I just know you've all been waiting to ask me. Could this be another potential place beyond Earth to look for life? Sadly, this ocean is likely to be a fleeting phenomenon. The very act of sloshing water around inside the moon dissipates energy. This acts as a brake, circularizing the orbit. As the orbit becomes more circular, the tidal stretching stops and the heat source turns off. This is also how we know that the ocean must be new. If it was ancient, Mimas' orbit would already be circular. Our best guesses put this cool down happening somewhere on the scale of millions of years. But who knows, that may or may not be long enough for life to get going. We are lucky to be living in the brief window where Mimas is an ocean world. As its orbit settles down, the ocean will eventually begin to refreeze, and this refreezing will be destructive. As water turns to ice, it expands. This expansion will push outward on the crust, likely shattering it and creating massive canyons similar to those we see on Saturn or Dione. It turns out that the Mimas we see today is a snapshot of a world in transition, a change that will eventually destroy the moon as we know it. The story of Mimas is a humbling lesson in planetary science. For centuries, we saw a cratered grey wasteland and assumed it was devoid of activity. We saw the Death Star and assumed it was a bringer of destruction, not a cradle of potential habitability. But nature is far more creative than our assumptions. The confirmation of an ocean on Mimas suggests that liquid water might be far more common than we ever dared to dream. If a small, unassuming world like Mimas can hide a global ocean, what about the moons of Uranus? What about the objects in the Kuiper belt? Mimas has taught us that even the dead worlds might have a heartbeat. We just have to look close enough to find it. If you've ever watched an Astrum video and found yourself pausing just to take in the beauty of space, you're not alone. The colors, the motion, the scale, they remind us how vast and awe-inspiring the universe really is. Have you ever had your breath taken away when seeing these videos of our Sun, Milky Way, or perhaps Venus? Well, now, Patreon members have access to these wallpapers for your phone and laptop. Sign up with the link below. It's a simple way to bring that sense of wonder into your daily life while supporting future Astrum creations.